Good morning, students. Hope you are fine and safe. It's been a long time since we have studied chemistry, so let's get started today. So first of all, I'm going to teach you acid, bases and salts, that is chapter 3A in your textbook. So before starting the lesson, I want you all to note down a few points. That is, you should learn the radicals, symbols and their valences thoroughly, for which you can refer the 9th standard textbook, the valency chart. So first of all, we'll study acids in detail. For example, you can see here dilute sulfuric acid. When added to a base, copper oxide, you get a salt, copper sulfate. Hope you remember the color of the salt, a pale blue salt. So let's start with acids. Acid is a word derived from Latin word acidus, meaning sour. Acids are sour to taste. A definition of acid. An acid is a compound which, when dissolved in water, yields hydronium ion as the only positively charged ion. Acid is a compound which, when dissolved in water, produces hydronium ion as the only positively charged ion. For example, can take hydrochloric acid, HCl. HCl dissociates to give H plus and Cl minus ion in aqueous solution. H plus ion further combines with water to form hydronium ion as the only positively charged ion. The overall equation will be HCl plus H2O gives hydronium ion plus chloride ion. So the definition is acid is a compound which, when combines with water, forms hydronium ion as the only positively charged ion. So next, going to the classification of acids. Acids can be classified into based on various factors. The first one is based on its source. The source is from where it is obtained. Acids can be classified based on the source into organic acids and inorganic acids. First, we'll study about organic acid. Organic acid is derived mainly from plants and in some insects. Example of organic acids are citric acid. Citric acid is derived from citrus fruits. Formic acid is derived from ants, or it is found in the toxin of ants and bees. So based on the source, acids can be classified into organic acid, that is, it is found in plants and insects, and inorganic acids are derived from minerals. Inorganic acids are derived from minerals. Example, hydrochloric acid, nitric acid, sulfuric acid. Hydrochloric acid is derived from sodium chloride. Nitric acid is derived from potassium nitrate or sodium nitrate. Sulfuric acid is derived from potassium sulfate or sodium sulfate. Sodium chloride, potassium nitrate and potassium sulfate are the minerals, and hence these are also called as mineral acids. Inorganic acids are also called as mineral acids. So now, based on the source, it is classified into organic and inorganic acid. The next is based on its composition. Based on the composition of an acid, composition is the elements present in an acid. Based on the composition, acids are classified into hydracids and oxyacids. Hydracids and oxyacids. Hydracid. Hydracid contains hydrogen and another element other than oxygen. Hydracids contain hydrogen and another element other than oxygen. Example, hydrochloric acid, hydrogen bromide, hydrogen iodide. Oxyacids contain hydrogen, oxygen and another element which is a non-metal. Example, sulfuric acid, nitric acid, etc. You have hydrogen, you have oxygen, one more element, sulfur. Hydrogen, oxygen, nitrogen. So based on the composition, acids can be classified into hydracids and oxyacid. So this is the second method of classification. Based on the strength of an acid, acids can be classified into strong acids and weak acid. Strong acid almost completely dissociates in aqueous solution to produce high concentration of H+ ion or hydronium ion. Example, nitric acid HNO3 combines with water to give H3O+ ion, hydronium ion and nitrate ion. Sulfuric acid combines with water to produce hydronium ion and sulfate ion. The solutions of these acids contain almost only ions. That is, all the molecules of acid gets dissociated to form hydronium ion. Therefore, the solution contains mostly ions only. Weak acids dissociate partially, producing low concentration of H+ ion or hydronium ion. Example, acetic acid, that is CH3COH, in aqueous solution produces acetate and H+ ion. Acetic acid, being a weak acid, contains molecules and ions in its solution. The next classification is based on concentration of an acid. Based on concentration, acids can be classified into concentrated acid and dilute acid. Concentrated acid, in the concentrated acid you find the percentage of acid is relatively high compared to water. Whereas in dilute acid you find the percentage of acid is relatively low compared to water. So based on the amount of acid present in water, it can be classified into concentrated acid and dilute acid. There is no particular example for this. Any acid can be concentrated or a dilute acid. The next method of classification is based on basicity of an acid. What is the meaning of basicity? Basicity is the number of H+ ions produced per molecule of an acid. Basicity is the number of H+ ions produced per molecule of an acid. Based on basicity, acids can be classified into monobasic, dibasic and tribasic acids. Monobasic acids, basicity is 1. That is, monobasic acids ionizes in aqueous solution to produce 1 H+ ion per molecule of an acid. Monobasic acids dissociate in one step. Example, hydrochloric acid is a monobasic acid. Combines with water to dissociate, forming hydronium ion and chloride ion. One hydronium ion is formed. It forms one type of salt, that is the normal salt. Example, sodium chloride. There are different types of salts which we will be studying under salts. So one such salt is normal salt. Monobasic acids form normal salt. Example, hydrochloric acid combines with sodium hydroxide to give sodium chloride and water. Dibasic acid. Dibasic acid ionizes in aqueous solution to produce 2 H plus ion per molecule of an acid. That is, each molecule of an acid will produce 2 H plus ions, or make it contains 2 replaceable H plus ion per molecule. So since it's a dibasic acid, the reaction takes place in 2 steps. They dissociate in 2 steps. That is, in each step, one hydronium ion is formed, or one H plus ion gets displaced. Sulfuric acid H2SO4 combines with water to form H3O plus one hydrogen displaces here, combines with H2O to form HSO4, H3O plus, and then what is remaining is HSO4. The valency of HSO4 is 1, so minus. Then the HSO4 minus combines with water, dissociates to form H3O plus ion and SO4 2 minus. Here the one hydrogen which is present combines with water to form another ion, hydronium ion and sulfate ion. The final equation is cancel out the like terms on the opposite sides, that is HSO4. HSO4 gets cancelled. The final equation will be sulfuric acid plus 2 molecules of water dissociates to produce 2 hydronium ions and sulfate ion. Since it's a dibasic acid, the reaction takes place in 2 steps. Since dibasic acids undergoes reaction in 2 steps, 2 types of salts are formed. One is normal salt and the other is acid salt. Example of a dibasic acid is sulfuric acid. When it combines with the base sodium hydroxide, it forms an acid salt, that is NaHSO4, sodium bisulfate or sodium hydrogen sulfate and water. Again, sulfuric acid combines with sodium hydroxide to form sodium sulfate and water. This is a normal salt, that is sodium sulfate. So this depends on the availability of the base. If the base available is sufficient, then you get a normal salt to neutralize the whole of the acid. If the availability of sodium hydroxide is insufficient, then sulfuric acid does not get completely neutralized. So you get an acid salt being formed. So we get 2 types of salt formed with a dibasic acid, acid salt and normal salt. The next is tribasic acid. Tribasic acid ionizes in aqueous solution to produce 3 H plus ion per molecule of an acid. Or it can be defined as it contains 3 replaceable H plus ions per molecule. Example, H3PO4, that is phosphoric acid. Tribasic acids dissociate in 3 steps. Example, phosphoric acid H3PO4 combines with water, dissociates to produce hydronium ion plus H2PO4 ion. That is, one of the H combines with water to form hydronium ion. The rest is H2PO4, H2PO4 minus. This H2PO4 minus ion further combines with water to dissociate to form hydronium ion plus HPO4 2 minus. These are the valencies. So one more H hydrogen atom gets combined with water to form hydronium ion and HPO4 ion. So the next step you have HPO4 2 minus ion, which further combines with water, dissociates to form hydronium ion plus what is left out now is only PO4 3 minus phosphate ion. So you have the first step, one hydrogen being displaced to form hydronium ion and dihydrogen phosphate ion. The second step, dihydrogen phosphate further combines with water, dissociates forming hydronium ion. One more H combines with this forming hydronium ion and hydrogen phosphate. Valency is 2 minus. And HPO4 2 minus further combines with water, dissociates forming hydronium ion and phosphate ion. The final reaction or the final step is cancel out the like terms on the opposite sides and then add up the equation, all the three steps. So the common factor is H2PO4 minus H2PO4 minus HPO4 2 minus HPO4 2 minus. Now you write the final equation. H3PO4 plus 1, 2, 3 molecules of water dissociating to form 1, 2, 3 H3O plus ion, hydrogen ion plus phosphate ion. So tribasic acid dissociates in 3 steps. In each step, one hydrogen gets displaced. And so the final equation is phosphoric acid combines with water and dissociates to form 3 hydronium ion per molecule of the acid and phosphate ion. Tribasic acids dissociate in 3 steps. Therefore, they form 3 salts, that is 2 types. One is a normal salt and 2 acid salts are formed. For example, sodium hydroxide as a base combines with phosphoric acid to form salt and water. Because it's an acid and base, so therefore it's a neutralization reaction, so salt and water are formed. So in the first step, only one hydrogen gets displaced to form water. So you get OH plus H, H2O. The remaining will be NaH2PO4. The second step or the second salt which is formed with sodium hydroxide is sodium hydroxide plus phosphoric acid forming Na2HPO4 plus H2. So the valency of HPO4 is 2. So therefore it is Na2HPO4. Whereas the valency of H2PO4 is 1. Therefore here it is NaH2PO4. The third salt which is formed with sodium hydroxide and phosphoric acid is a normal salt. Here there is a complete replacement of the hydrogen of the acid. There is complete neutralization of the acid and base here. So you get a salt being formed, that is Na3PO4. You can see PO4's valency is 3. So therefore it is Na3PO4 plus H2O. So these two contain hydrogen in them. So these two salts are called acid salts. And sodium phosphate is a normal salt. Name of the salt is monosodium dihydrogen phosphate, and the name of this salt is disodium hydrogen phosphate. So let's check for balancing of the equation. The first equation is balanced. The second equation, you find there are 2 sodium here. So therefore sodium has to be balanced. So 2 NaOH. So when you balance sodium, oxygen and hydrogen also changes. So check for hydrogen and oxygen. So you have here 2 plus 3, 5 hydrogens. Whereas here you have 3. So therefore you can write a 2 here. 2 2s are 4 plus 1, 5 hydrogen. Then sodium, we have 3 atoms of sodium here. So therefore here it should be 3 NaOH. So check for oxygen and hydrogen. So you find here you have to add a 3 so that the hydrogen and oxygen are balanced. 3 2s are 3 plus 3 6. Here 3 2s are 6 hydrogen and 3 plus 4 7 oxygen and 3 plus 4 7 oxygen. So the equation is balanced. Preparation of acids. Acids can be prepared by various methods. The first one is acids from nonmetals. The examples taken here are chlorine and iodine as nonmetals. Hydrogen combines with chlorine to form hydrochloric acid. Hydrogen combines with iodine to form hydrogen iodide. So from nonmetals, chlorine and iodine, when they combine with hydrogen, hydrochloric acid and hydroiodic acid can be formed. The second method is acids from acidic oxides. Now what are acidic oxides? Acidic oxides are oxides of nonmetal. The examples of acidic oxides are carbon dioxide, sulfur dioxide, sulfur trioxide, phosphorus pentoxide and nitrogen dioxide. These, when they combine with water, they form respective acids. Carbon dioxide combines with water to form carbonic acid, H2CO3. Sulfur dioxide combines with water to form sulfurous acid, H2SO3. And sulfur trioxide combines with water to form sulfuric acid. Phosphorus pentoxide combines with water to form phosphoric acid. Nitrogen dioxide combines with water to form two acids, which we have done in 9th standard. So I leave this for you to complete it. Nitrogen dioxide combines with water to form two acids, which I have already learnt in 9th. So I want you to complete this. So carbon dioxide with water forms carbonic acid. Sulfur dioxide with water forms sulfurous acid, and sulfur trioxide with water forms sulfuric acid. Phosphorus pentoxide with water forms phosphoric acid. Now check for the balancing of the equation. The first three equations are balanced. The fourth one has to be balanced. So you write 3 water molecules forming 2 molecules of phosphoric acid. So this I leave it for you to complete. Then the third method of preparing acids are from salts. The salts which are taken as example are sodium chloride and potassium nitrate. Sodium chloride combines with concentrated sulfuric acid to form sodium hydrogen sulfate and hydrogen chloride gas. Here hydrochloric acid is not directly formed, hydrogen chloride gas is formed, which when dissolved in water produces hydrochloric acid. Sodium chloride combines with concentrated sulfuric acid to form sodium sulfate and hydrogen chloride gas. Here you can see the reactants are the same, but the products, there are two different types of salts formed because sulfuric acid is a dibasic acid. The formation of salt, that is a acid salt or a normal salt, depends on the temperature of the reaction. The temperature of the reaction is maintained below 200 degrees Celsius. Then you get an acid salt. The temperature of the reaction is more than 200 degrees Celsius, you get a normal salt. This also depends on the concentration of the acid. So concentrated sulfuric acid combines with sodium chloride to form sodium bisulfate. The temperature is below 200 degrees Celsius. The temperature is above 200 degrees Celsius. It forms sodium sulfate. Then the next salt taken as an example is potassium nitrate. Potassium nitrate combines with concentrated sulfuric acid to form potassium bisulfate and hydrogen chloride gas. Here again you get an acid salt because the temperature is below 200 degrees Celsius. If the temperature is above 200 degrees Celsius, you get a normal salt, that will be potassium sulfate. So the fourth method of preparing an acid by oxidation of nonmetals. The example taken here is sulfur. The non-metal sulfur is taken as an example. Sulfur combines with concentrated nitric acid to form sulfuric acid. Sulfur gets oxidized to sulfuric acid. And water and nitrogen dioxide are the other products formed. Reaction has to be balanced. When you balance the equation, 6 molecules of nitric acid combines with 1 molecule of sulfur to form 1 molecule of sulfuric acid, 2 molecules of water and 6 molecules of nitrogen dioxide. So with this we complete the preparation of acids by various methods. The next is properties of acid. Properties of acids are physical properties and chemical properties. The physical properties of acids are they are sour to taste and they are highly corrosive. They turn blue litmus red, methyl orange pink. Next is chemical properties of acids. Neutralization reaction is a chemical property of an acid. Acids neutralize bases to form salt and water. Hydrochloric acid is taken as an example. When it combines with sodium hydroxide, which is a base, it forms the salt, sodium chloride and water. Sulfuric acid combines with copper 2 oxide, which is also a base, to form copper sulfate and water. Bases can be hydroxides or oxides of metals. The second chemical property is acids react with active metals, that is dilute acids, react with active metals to liberate hydrogen gas. What are active metals? Active metals are metals which are present in the activity series above hydrogen. One example is zinc. Zinc combines with hydrochloric acid to form zinc chloride and hydrogen. here the reaction has to be balanced because there are 2 molecules of chlorine and 2 molecules of hydrogen. Sorry, 1 molecule of 2 atoms of hydrogen and 2 atoms of chlorine. So therefore it has to be 2 HCl. Then the third chemical property is reaction of acids with chlorides, nitrates, bicarbonates and carbonates. The first one is a chloride. Example taken is sodium chloride. Sodium chloride combines with concentrated sulfuric acid to form sodium bisulfate and hydrogen chloride gas. Now here the temperature has to be mentioned. It is below 200 degrees Celsius. Sodium nitrate combines with concentrated sulfuric acid to form sodium bisulfate. This is an example taken for a nitrate, sodium nitrate. So you get sodium bisulfate and nitric acid. So here again the temperature has to be mentioned, which is below 200 degrees Celsius. Whenever the temperature is below 200 degrees Celsius, an acid salt is formed. The next is an example for a bicarbonate, sodium bicarbonate plus this dilute sulfuric acid. Dilute sulfuric acid produces sodium sulfate plus water and carbon dioxide. So here just check for the balancing of the equation. Sodium 1 atom, whereas you have 2 atoms of sodium here. So therefore it has to be balanced. So you write 2 NaHCO3 and then check for hydrogen and oxygen. So you find 2 molecules of water and 2 molecules of carbon dioxide. The next is an example for a carbonate, sodium carbonate. Sodium carbonate combines with dilute hydrochloric acid to form salt water and carbon dioxide. Carbonates will give carbon dioxide as one of the product. Bicarbonate and carbonate. The sodium carbonate dilute hydrochloric acid gives sodium chloride plus water plus carbon dioxide. Here again the equation has to be balanced. There are 2 atoms of sodium here, whereas 1 here is 2 NaCl and chlorine is 2, so here 2 HCl. The next is uses of acids. Various acids are used for various purposes. Boric acid is used as an eye wash. Citric acid is used for preserving food. Oxalic acid is used to remove ink stain. Carbonic acid is used in soft drinks, which is flavoring of drinks. Tartaric acid is found in baking powder, and acetic acid is found in vinegar, which is used for cooking. Hydrochloric acid is used for pickling of metals. Pickling means to remove the oxide layer on the metal. With this we complete acids. Let's continue with bases in the next video. Thank you.